Okay, great. You can hear me okay?
Yes.
All right, wonderful. Yeah, thanks everyone for joining. I am super excited to do a webinar, or I should say an information session really on everything you need to get your first PCB manufactured. And I'm sure many of you have already manufactured circuit boards, but if there are any uh, first timers, please definitely raise your hand or ask a question. And even for people who, this is old hat for, please ask a bunch of questions. That's how we can, tailor the conversation to be of value to you guys. So let's get started. Oh, that's me, by the way. Okay, so Sierra Circuits, just as a couple of things, we have, you know, lots of technology and we do everything in the Bay Area or Silicon Valley. So we do PCB fabrication, we do assembly, and we do components. Okay. And these are some of our kind of PCB capabilities and services that we offer. So please reach out to us and we'd be happy to give you guys a quote. This is the agenda for today. And also the agenda is open, so if you have any specific questions, we can definitely address those. But, I'd like to talk about how to assess as an engineer or as a, supply chain person, what's important to you and how would you assess a vendor or a fabricator? What should you be looking for? What's in the details? And then, if you're submitting for a quote or to be manufactured, what should you what pre-work should you do? What information should you send us? All those types of things we'll be going over in a couple of, it wouldn't be a good presentation without some pointers on DFM and DFA. So definitely going to touch on that. Just from a high level perspective first, really as you're the customer, what should you look for, when you're selecting your vendors and when you're working with a fabricator and an assembler? And then also, what do we look for as a supplier, in our customers? Because the truth is the market is humongous. There's plenty of business out there, and really our job as both you, the customer, and us as the vendor is to make sure there's a really good partnership and a really good fit. We don't want to disappoint customers and vice versa. You want to be a good customer to your vendors. So I think what I've seen in the industry is people really break it down into at least three kind of big buckets, which is, cost, what is your, opinion and, what are you paying for, the actual dollars out, but also realizing, the other soft costs. And by soft cost, I mean, if there's a problem with the board, or if you don't get the board on time, or if there's like a 6 week delay, what is that costing you as an engineer or you as a business? So I think you should consider all those costs, not just the cost that you're paying for unit price of a circuit board. And then there's the quality and technology. How do you really assess if the fabricator is able to, keep up with your quality and technology requirements? And then, of course, the lead time, I think, is what Sierra sells primarily, I think, is the last two, the quality, technology, and the lead time. And we're not so aggressive on, cost reduction for prototypes, because the key point in prototyping is getting things done quicker and really giving a lot of feedback. So if your main focus is only cost, then we probably are not a good vendor choice. Um, so as a customer, or, how should you analyze a manufacturer's capabilities? So, and what are the key points to analyze? So here's most fabricators have their capabilities. Just realize if you're doing something that's standard, the capability guidelines are going to work for you. If you're doing anything non-standard, the capability guidelines are only a reference and they probably don't completely apply because lots of capability guidelines by themselves, are accurate, but together with a system like a board, which has a z-axis, things don't necessarily apply. A very simple example is if you pick a very, difficult to work with material, having multiple sublams and laminations would, for a difficult to work with material, be much different than, picking like a regular FR4 or a high temp FR4 and having multiple sublams. Those are two completely different builds. So knowing the right material for the right build strategy, and then, basic things like, are you building a class 2 board or a class 3 board? And if you're building a class 3, understand how, the capabilities fit that because a class 3 requires, more copper in the hole. A class 3 requires wrap requirements. A class 3 requires, other inspection criterias that class 2 doesn't need. Okay, I spent a lot of time on that, but it's really important to assess whether your fabricator can build your board. It's not just based on their website. You really need to talk to them. So then, the next thing is that, once you kind of really assess properly that your fabricator has the capabilities on their website, you need to also assess that do you have the right information for the fabricator? If you're doing a fab and assembly, you should really be providing the ODB data or the IPC 21 data, and that would set your fabricator and assembler up for success. And then second, which we'll touch on later as well, is do you have the proper notes and information outlined for your fabricator and assembler, again, to set them up for success? So your board the best. Someone like us, we're going through many, many part numbers per day, and it would be very helpful if customers or potential customers, they outline what they've seen as critical to them. And we'll go over that in more detail as well. So I just kind of want to summarize, this first kind of selection part or assessment part before you kind of go down a relationship path with a fabricator. So your job is to know a little bit about your board and how complicated it is. And if there's any specialty materials, I would say the first question to ask your fabricator is, do you have experience with this material? If they don't have experience with the material, but the material is easy to work with, the build can still be successful. However, if it's a complicated build, again, complicated, I would say is, not just many layers, but sublams, and maybe it's a dense board with lots of components and tracing space gaps. Even if tracing space gaps are 4 mils or 3 mils, it can still be a very challenging build because of density. In those cases, if a vendor, a PCB fabricator has not worked with that PCB material before, they don't have any scaling data. And if you don't have any scaling data, then you're basically, the fabricator is, using your board to collect the first set of information about how this material is going to move. So a data sheet can say something, the material vendor can say something, but it really comes down to actually how does that material perform for your stack up, in that factory. And if it's the first time, you can definitely need to, bake in more lead time for your fabricator. So don't expect a quick turn. 5 days or less would be an unrealistic expectation for that vendor. Second is if you feel that your board is a little technical, you can ask the fabricator, and I think everyone would like to be be honest about it. But, what is the yield that they're expecting from this, combination of factors? Because as a vendor, we don't want to take on work where our yield is not going to be good because it disappoints the customer and it also costs us money. All of our profit will go into, the scrap. And it's very hard to actually charge customer for scrap, right? No one wants to pay for scrap. So part of our assessment before we, start a relationship or even build that specific part is we do a pretty detailed assessment of what is the risk factors for us to build that product. And when we're assessing the risk, if it is outside of our comfort zone, but we still think there's a potential for us to build that successfully, we would be upfront about that and say that, we're probably going to have to run a first article. And it's going to take a little longer, but we think we can be successful on that build. And so these questions and conversations should happen prior to, releasing the order. So if our account manager doesn't bring these things up and it's a difficult build, it's important for you as a potential customer or a customer to initiate that conversation. And then on the assembly side, that's also a very important dialogue. Maybe the board is not complicated, but the assembly has some things that the assembler should look out for. Same thing, like having that discussion of, what are the sensitive parts and what are some special handling or manufacturing instructions that, need to be presented, and it's better always before the build starts. So this is, it may sound like a lot, I don't know, but this is what I would do if I was a customer and I would have these, conversations. Could be no more than 10 minutes, but really just kind of lining everything up. And then once you establish a relationship, then, things just, you don't even need to have this type of conversation. You kind of know, and the vendor knows, what the relationship looks like and what we can build and what we can't. So the other comment, if you're an engineer, I say this in every chance I get, is work with us ahead of time prior to your board being fully designed, because if you're designing to class 3 but you don't give enough annular ring, or even if you give enough annular ring but there's other issues with the layout that we can't meet a class 3 requirement, you'd want to know that ahead of time. You'd want your stack up designed prior to routing. You'd want to really know that component placement is even good. You can engage with us early on and get us to scrub your BOM if you want to help with that, and just use us as a resource even prior to placing the orders. That is the best way to have a successful prototype build. So we have a full set of engineers, manufacturing engineers and design engineers. They can help you with stack ups. They can help you assess, what would be critical about your design. And we do an initial, stack up, no problem. We'll do, component assistance if you need it. And, all that's there for you guys to take advantage of. And same thing, stack up and impedance calculator. And I think we're going to do a demo on that at some point. I think this is a good time to do a demo on impedance.
Yeah, sure, we can do a demo on impedance calculator. So.
Okay, great. Thank you.
Yeah. Hi, everyone. This is the impedance calculator tool here, and our Sierra Circuits impedance calculator tool supports 82 impedance models with multiple geometries, such as the uncoated, coated, and embedded microstrip and the strip line. And each of these specific models, you can choose single, differential pair, coplanar, or single-ended, etc. All of these geometries here. Let's go with coated microstrip in a differential pair, and we can see that the basic and the composite models are available here, and you can choose whichever one you want. Let's go with the basic pair for now. This impedance calculator is also integrated with the signal loss crosstalk and the S parameter calculator. I will be showing it to you in a moment. Here we can select the desired unit system. Let's go with mils for now and enter the input parameters. Let's go with dielectric H1, a dielectric constant of 3.63, a coating height H1C of 1.5 mils. The coating height H2C has a default value of 0.5 here, but you're free to change if you wish to do so. And then let's go with the coating height H3C. To calculate the trace width here, we need to enter delta W. Delta W is the difference between the top of the trace and the bottom of the trace. And you can click on this help guide here that displays a table that suggests delta W values based on the starting copper weight. Let's go with 0.5 for now. Enter a trace thickness, a trace separation, and a target differential impedance. Now click on calculate W and the trace width along with these other parameters that are shown here will be calculated and displayed. You can also do a reverse calculation where you calculate the differential impedance by entering a trace width. Now let's go to the signal loss calculator for the same chosen model. Here enter the dissipation factor, a frequency, surface roughness. 6 is a standard roughness for a foil, and let's go with a length of 2 inch. Click on calculate loss and the signal loss output in the odd and even mode will be calculated. Similarly, we can use the S parameter calculator, enter the source impedance and the load impedance. Select one of the output types here. You can go with complex or polar and click on calculate S parameters. Here, since we had chosen an uncoated differential microstrip, we can see that the differential pair has a 4-port network. Hence, we have two matrix outputs, the 4-port S parameter and the mixed mode S parameter. Along with this, the characteristic impedance and the propagation constant in the odd and even mode are calculated and displayed. Similarly, we can use a crosstalk calculator here for the same chosen model. Another note to remember is that to use the S parameter calculator, you have to make sure to use the signal loss calculator because the frequency that was entered there is used in the calculations here. Thank you so much.
Okay, thanks, Vandana. Let me see if I can properly reshare. Can you see my screen?
Yes.
Yes.
Okay, great. So, you know, the purpose of these calculators that Sierra has built is really to give back to the community of engineers that have worked with us over the years and also, build an awareness about Sierra. And they really are fantastic tools to help an engineer get their product working quicker. And, if you have impedance or signal integrity requirements, and don't have the super expensive tools, the tools that we're creating are really best in class. So I highly recommend that if you haven't checked them out, to definitely do so. And I see some questions coming in. So the Sierra team, if you guys can take a look at those. And also, I welcome as many questions as possible. That's how we also learn as to what's important to you guys. Now, going back to, how you should work with us, the more you engage with our tools or our bomb scrubber or even our design engineers, the more success chance you have, and that's really key. And so we have a design checklist. We're going to send that as an asset afterwards, but here's just a quick kind of overview. Make sure that you have a good description, that it matches the manufacturing part number, not just the, an internal part number, but it really should be an MPN that we can easily source from and quote from. And, we do have a database that can handle customer part numbers, but really we also need the MPNs. So this is an example of that, of, just having the right bill of material. And, a lot of our tools were internal tools as well as our online tools. We're checking for these things that I'm mentioning to you in terms of the BOM. But it's good to start off, building your BOM correctly from the beginning. So the other kind of data that we need, if you don't send us ODB, then you have to be aware of every single file. And one example for assembly is the XY data. And again, I was pointing out earlier, we really want ODB or IPC 2581 for assembly. But for whatever reason, if you can't supply that, make sure you have the right XY data format, good proper BOM as well, and then any assembly drawings outlining specific components that have special handling requirements, things like that. And then having an assembly drawing with, accurate and legible pin 1 markings is really, really nice. Okay, that was a lot on assembly, sorry. So here, going back to fab, here's some example fab notes. And on our website, we have a whole knowledge base section, which tries to, communicate how your fab note should look. And, I think that's a valuable resource. So copying and pasting notes, not the best practice. I know everyone does it, but really try and review your notes prior to sending those in. It just slows things down. If you have a note that doesn't apply to that design, we're trying to double check for accuracy, and we're like, okay, why is this note here? It doesn't make any sense. And so we'll feed that back to you, but as a designer, you should be double checking your notes. And these are the common notes that everyone should have. Solder mass, colors, copper weights, if those are important. You can go with our default copper weights. That is totally fine. You don't have to specify your copper weights for Sierra. It usually ends up being 1.5 on the outer layer. Yeah, so these are some of the key fab notes. Pay special attention to tolerances. So for example, a finished board thickness and the tolerance requirement, or assembly kind of requirements. Those are some important points. Sorry, hold on one sec. If you have any questions on your fab drawings, you can engage your design engineering team, and they can help on that. And we do have example fab drawings that you can, bring into your design database and go from there. Although, it's really dependent on your design. And then on the assembly side, you really want to make sure that you outline, as I was saying earlier, have good reference designators with polarity markings that are clear. Something that's not well practiced is fiducials. So if you have a type BGA or something, you can have a fiducial next to that component and call it out. And we would reference that when we're placing the component. And if you have any, wash or no wash requirements, I would put that on the assembly drawing. And any special type of cleaning or handling as we talked about. Now, somewhere in your notes, if you want us to save X-rays of our images as we're manufacturing your product, you can write that down and we'll do that. If you don't have that in your notes anywhere, then tell your account manager, and so we can save those X-ray images for you, so you can reference them for later. And another thing on assembly, if you have special quality requirements that are going to end up coming on the PO, it's better if you talk to the account manager about those quality requirements and connect with our quality engineers. First of all, we'll price it correctly. If you need traceability, or if you need certain data from the floor, if we know ahead of time, then we can actually price it for the activity level that you need, the traceability you need, and also make sure that we have it. Sometimes we'll X-ray and not save it, and sometimes the information you need is not collected on the floor. So that's really important to engage if you have special quality requirements, if you're in medical or aerospace or automotive, to engage with our quality engineers, so you get the right price and you get us to do the right work for you. So I think that's enough about assembly. Going back to just a shout out to 2581 and sending over data. If you go with the standard outputs of design packages, sometimes they give Gerber, ODB, and everything else under the sun. That's confusing for us because we don't know which one to go with. And sometimes the outputs are not the same. So it's very important as an engineer to output and then check the output. So if you're sending Gerber, use a Gerber viewer. If you're sending ODB, use an ODB viewer, or IPC, you can use an IPC viewer. Just make sure the data is good before you send it. That should be a part of your checklist. And when we send over that asset, you'll have that as as a part of your checklist before sending designs to any of your fabricators or assemblers. Once we get your design for quote, we are doing a quick set of DFM checks. And we don't do all the DFM checks at quote stage. So it's really important that if you need that you tell us that you want that. We can, for good partners, do the DFM, DFA upfront. Okay. But that's based on building relationships and letting us know ahead of time that this is something that you're looking for. And that would remove any delay after releasing the order to the floor. If you don't do that upfront, after the order is released, we do go through DFM and DFA, and that does take time, and it does delay your product. So our turn times are after no issues. That's when really the turn time starts. But going back to PCBs, I kind of touched on this, but getting your stack up correct even before layout is super important. Knowing that you pick the right materials based on your environment, knowing what the glass transition temperature needs to be or your dissipation factor. These are things that are on the data sheet of the PCB material. And we have a material selector. I don't think we're demoing that. But we have a material selector that's built into our stack up tool, and it says, hey, is this material conducive to high speed and specialty constructions like multiple laminations and HDI? So those are some really important points that we're able to share with you in our stack up tool. And then of course, you want your stack up to be symmetrical. So if you're not using one of our pre-baked stack ups, make sure you're taking that into account. And if for signal integrity concerns, make sure you're properly, picking, which layer does what as it relates to, your high speed requirements. That's also very critical. And we've done many webinars on that as well. So I'll pass it over to Vandana to do a PCB stack up demo.
Hi everyone. So our PCB Stackup Designer tool provides manufacturable and cost optimized stackups. It also has the impedance calculator built in the tool. It allows you to change the signal plane combination and the copper weights in the generated stackup. We also allow you, the tool also allows you to download the stackup data in IPC standard 2581. Here we first start by entering the board information. Let's go with the project name. Enter a revision number. Enter the PCB size. You can use this drop down to choose the target PCB thickness, Similarly, we have a list of PCB materials here. You can choose one of those, the PCB type, and you can also use this material selector compare guide, to compare or view the data sheets of various materials and compare their attributes. Now, in the stack up design method, you need to choose one of these options. If you know the number of layers that are required in your design, then you choose this first option here. Or if you have a complex BGA that dictates the number of signal plane layers in your board, then choose the second option. Now you enter the layer count here. Then choose a signal plane combination and click on Run Stackup Designer. You will be presented with a Sierra Circuit's recommended stackups here. This table gives the stackup information like the signal plane layers, if it's a standard or HDI stackup, the technology level and cost index. You can click on this report button to view the final stackup that resembles your build-up. So now in this report page, you can view the attributes without going back to the previous page. And if suppose you do any changes over here to the PCB, then make sure to click on Generate Custom Stackup to update. When you scroll down further, you see a detailed construction of the chosen stackup. Here, you can change the layer type. Let's change the signal layer to a mixed layer, and we can see that the copper percentage is automatically adjusted. We can click on this symbol here on top to remove the solder mask if you want. And then you scroll down and you see the built-in impedance calculator. Click on this plus sign here to add in a fresh line and enter the information. For example, you can choose the signal layer here on which the line exists, and then you enter the target impedance, add a model type, select your reference layer, and the transmission line model will be automatically chosen. You can click on calculate here now, and the trace width, propagation delay, and the impedance, calculated impedance will be displayed here. You can also click on this view button that opens the whole of the impedance calculator tool, and you can view the other parameters as well. Then we have the technology parameters and cost index that has been shown here for this particular stack up. Now you can click on this save button here, and by doing so, it generates an ID that allows you to, view or access the stackup in the future sessions. You can click on this export to IPC 2581, and this will import all the stackup data in a .xml file, which can be implemented to any ECAD tool which supports IPC 2581. Yeah, thank you.
Thanks, Vandana. We're getting some good questions, so that's great. Lucy, can you respond to some of the reference material questions, or Raul? People are asking for, references to more information, like our bomb scrubber and, other kind of informational things. If you can,
Yeah,
if you
sure.
can reference that, that'll be great.
Mm-hmm.
Okay, great. So if I can address some of the questions during the conversation, I will. Otherwise, we can do it after. But thanks, Vandana, for that pointers on how to use the stackup tool. And I think it's really important to assess how many layers and how are you going to surround, which layers are going to have the critical nets on them, and then how are you going to reference those critical nets or surround them with proper grounding. And I think all those decisions do need to happen at the stackup stage. And then in terms of route density, you should also have an assessment of that. And honestly, the stackup tool does include a lot of that thought process. So, if you are worried about routing density, the stackup tool can handle that. So I highly encourage using the stackup tool as a reference, even if it's not the final stackup that you go with, but at least a starting point. I think it would be really amazing. Okay, so I think there's enough engineers on the call. I think I'll go into some kind of DFM, guidelines. So I want to call out something. I don't really have a slide for that, but it's important for all engineers to understand what parallel traces can do to a fabricator, right? So if you have, this was going back to my example, if a fabricator says they can do 3 mil trace in space as standard technology, and then the designer designs a whole bunch of traces that are parallel and long running across, large spaces of the board. There's many problems with that. Both, you have to make sure that you don't have, interference and it doesn't impact signal integrity. Second, a fabricator, when they're going through their process, especially their wet processes, and Steve Carney can explain more, but parallel traces do pose a problem in traditional PCB manufacturing. And you could have yield issues, right? So I'm going through that with one of our customers right now. They have an inner layer core. It's very expensive. It's part of a 26 layer stack up, and they have parallel lines all across this big board. And they're wondering, why we're scrapping those inner layer cores. And it's just the nature of the design. No matter how good the fabricator is at controlling its processes, that design is not conducive to high yield. Now, thankfully, it's not, in the thousands of pieces, so something we can manage. But as a designer, understand that parallel traces are not good design practice. And if you have parallel traces, then really space them out as much as humanly possible. Okay, so that being said, you should also be cognizant of how close you can have copper to the edge of the board. In some cases, you want copper really close to the edge of the board, maybe more shielding, or you have like RF connectors. Understand what your fabricator's capabilities are. Right now, we have vision routing, so we're at plus or minus 2 mil on the outline of the board. And if the board gets thicker, like 0.25 inches thick, that route tolerance will change. But if it's a standard 062, we can hold a plus or minus 2 on the edge of the board. And for flex, that's also different. Most fabricators that do flex are using laser to route the flex. So again, it's very accurate and scales. But you do need to be able to talk to your fabricator and understand their tolerances before you lay out your copper. If you don't, then good manufacturers will push back and say, hey, can we pull this copper back? And we're basically editing your design to make it more manufacturable. And if I was a designer, I would want to have the single source of truth of the design. Especially on things like pulling copper features back. So anyways, that's a nuance, but I think it's important. And then, in terms of what we're capable of doing, we are working on processes to get reliable sub 2 mil trace in space. And if you have those types of requirements, we'd love to discuss those with you and see how we can help. Next, of course, is annular ring is kind of the number one, question that we get from designers. Annular ring is another example where it depends on class 2 versus class 3. It also depends on your stack up and where the sublams are. So it's really important to discuss with your fabricator the build strategy and whether your design will meet that build strategy prior to finishing your layout. Once you've kind of designed everything, and it's really hard to move things around at that point, especially if you have a dense design. So definitely encourage that conversation. So one thing for aspect ratios of microvias, we do prefer 0.75 to 1. We can do 1 to 1, but don't prefer it, and you can have issues. So definitely try and keep it in 0.75 to 1. And if you have impedance requirements that negate that and don't make it possible, then these are types of designs where you definitely need to discuss with us upfront and not just throw us something over the wall. And then the other thing which I hope your senior designers consider is drill to copper. So as a fabricator, we're always going to drill a little bit larger than the finished hole size, which you specify in your drill chart. And the drill to copper is from the drilled hole wall to the next copper feature, be it a ground plane or trace on any layer. So it's important for you to be cognizant of that. And even if your DRCs don't check that, to check it yourself. It's a couple of steps you can check your own DRC. We also have a better DFM system on our website, which basically remote controls our very expensive DFM tool. You're free to upload your data and you'll get back all the, DFM information in terms of spacings and drill coppers and, all of that. And it's completely free and it's ITAR. So don't feel that you can't upload your data there. It's all very well protected. Now, in terms of solder mask, so there's solder masks that a fab shop can build, and then there's solder masks that you need for assembly. Both are important. So when we were just a fab shop, we would often ask customers to gang relief, and which is not the best for assemblies. But now that we're both fab and assembly, we don't really ask very often to do that because it's just only going to cause problems downstream. But as you're designing, make sure you properly put enough webbing in your design. And if there's things that you can't, for some reason you can't do it, then definitely talk to us. We have different ways to incorporate tighter designs. I think most fabricators are using LDI to image and expose the solder mask layers. Also, green is the best solder mask, and only if you're going to get fired for not using green should you use any other color. Although we do other colors, it's just different in terms of the manufacturing processes. So I'm being a little facetious, but I highly think you should stick with green. If you don't stick with green, then know all the nuances of different colors, like black. And then silkscreen, we do have some silkscreen guidelines for, minimum widths and, the heights. Silkscreen is really important for the AOI machine, but you want to make sure that it's clear and legible and not falling on the pads. So these are the things that can happen if you're not paying attention to DFM or your fabricator doesn't offer solid DFM. And I just want to say that assembly DFA is different from fab DFM. People I've seen in the industry, they're like, oh yeah, we do DFM, but if they're not a PCB fabricator, they're really not doing DFM. I mean, I really feel strongly about that. A fabricator is a fabricator. Fabricator knows how to build a board. An assembly shop knows how to assemble a board. And, us being both, we absolutely cross-pollinate every single day. Every single day, the fabrication team is learning something from the assembly shop, and every single day, the assembly shop is learning something from the fabrication team. And I'll give you an example. We're doing some critical boards with wire bonding. Sorry, I'm digressing, but this is a very important comment. If on the assembly side, you have some keep out area where you can't have any FOD, you want a super clean area. Washing only can get you so far. It's better to cover that area. And if it's a production build, you don't necessarily want to cover with tape. Tape can also leave residue. So on the fabrication side, there's something called peelable mask. And peelable mask is not a universal solution. It's very difficult to do, and it requires that your design fits that solution, but it can be a great solution that at the end of the fab and the assembly process, that area, let's say wire bond pads or whatnot, would be super clean for the follow-on processes. So those are the types of process engineerings that we do with our customers to come up with solutions. And then it's important for you guys to consider as well. You know, other things, you know, every fabricator has rules around spacings because of slivers, and slivers can be an issue in design. So be careful how you design your board, and if your fabricator, you know, what those rules are for spacing, and make sure you don't have any slivers. So we check it, but not every fabricator may check for slivers. So just a quick checklist, and again, we can send over a more detailed checklist, but you know, from a DFA standpoint, you want to make sure that you verify your footprints, and if you're not doing it, we're doing it. Verify pin 1 and polarity. Make sure you have the right spacing. If you can provide test points, all the better. We can use the test points at Flying Probe after assembly. You can ping us for our design guide on Flying Probe test, or just download it from our website. But test points need to have their clearances and their size so it can properly probe. You know, be cognizant of component heights and how someone's going to get in there for either manual work or just testing again. So these are some of the DFM steps. And again, we don't like to start manufacturing until DFM, DFA is complete. So think about that and add that to your overall cycle time. And the cycle time we quote is just for manufacturing, assuming that your design is good. Some points on signal integrity. So I already mentioned kind of that parallel traces. If you have any kind of high speed requirements, parallel traces are a disaster. You don't want to do that. And if you have special requirements, really consider, you know, having proper termination resistors, and we have a whole webinar on how to properly terminate. And then, of course, if you can have proper ground plane design, that'd be great. If you do have split planes, you know, be very cognizant of how you route in referencing those split planes. And then via stitching is great. I highly encourage that. And we have guidelines on how far apart to put your vias. You know, you don't have to go crazy on the number of vias. You just have to do, you know, follow guidelines for proper via stitching, and it won't increase your cost of the board too much, and it'll get you excellent signal integrity. So how to, you know, quote and order PCBs. Every board shop's going to be a little different. You know, for us, we want you to supply the right materials, the right files, and as much information as possible. And if you're a regular customer, please reference any down revisions that we've built for you before, because it's hard for us to guess. And our systems only go so far in understanding if we've built this for you before, and it'll help us get through the DFM, DFA process faster if you've made a decision in the past. So referencing previous builds is a key thing, I think, when you're quoting. You know, not asking for so many quantities if you're really not going to place the order for, you know, all that. It's nice information to have, but it's also not realistic. Every time you ask for, let's say you ask for 50, 100, 1,000, where each one of those are separate exercises, especially on the component side. So maybe at 1,000 pieces, there's nothing available right now. So you know, we're going to post all those issues back to you, but if you know that you're only going to build 50, then, you know, just quote for 50. I mean, that's my advice. You'll get your quote back faster, and and you can be off and running. In parallel, after that, if you want a budgetary exercise, we're more than willing to do that. But I think you should decouple those so you can get your quote back faster and place your orders. The other thing after quote, we do find issues. We're posting everything into our homegrown project portal. So if you haven't seen that, I think there's a lot of value there. And in that, you should set up access control properly amongst your teams. So if it's just you, then only you need access. But if you have a larger team, let's say multiple designers, or a backup designer or quality engineers or supply chain, you can set up the project for the right people to get the right information that they need, like the quality documents I was referencing earlier, or if there's if supply chain wants to pay for an order or know how many we ordered last time. It's a great tool. It's a great resource. Also, we've created this new process called ECO. So after an order is released, prior to the job being on the floor, it's really not an ECO. But after the job's like pretty much on the floor, it's definitely an ECO. And ECOs do require extra work on our part, so there might be a small ding in terms of cost. Then please expect that, because we may have already gotten the ball rolling in so many process steps and it's all throwaway work. So there may be a charge for ECO, but if it's something you need done, then we'll be happy to incorporate that even on a prototype. Okay. So going into the project, you can make a change request, and everyone within Sierra knows about that change request as soon as you enter that. So before, it was really bottlenecked by the salesperson and who the salesperson communicates internally. And this platform allows the right people to get the information quickly. So I highly encourage that if you have any concern, question, or change, you go to the project and you make it known there. That's what it's for. And then it's all traceable. So traceability is really key, when you have a critical build. So Sierra, I think, is really good at giving lots of feedback and helping you get to a design that works faster, both from an electrical standpoint as well as from a manufacturability standpoint. And I've come across many customers that, they're submitting designs to us, they get boards back, they just work. And with other fabricators, they're not working. And God knows why, right? It's going to take forever to figure out why another fabricator is not producing a board that is functioning, even though they're meeting all the specs. So I don't wish that upon anybody, but we definitely deliver a good product to our customers. And if we don't, if there's a hiccup, we absolutely own it. And if we can work with customers in a reasonable fashion, it just makes the relationship that much better. Here's an example of, I didn't mention it earlier, and I think that was a mistake on my end. It's really important to understand, does the fabricator do cross sections, and they do them religiously? And when do they do cross sections? So there's a requirement for IPC class 2 and class 3 to have coupons on your sheets that you're building, even if you don't request it. But I would, as a customer, always request my cross section. And you can ask the fabricator if they do in-process cross sections and at what key steps do they do them at. Sierra does in-process cross sections after lamination and after plating. And then there's coupons that represent every via structure. And we're cross-sectioning all the different via structures to make sure that everything was laminated properly, plated properly, good reliable circuit board meeting the spec requirement. So that's what we do to ensure a good quality product. And that's all I have for you. I know there's some questions, so I think we can go through those. And if you have more, please feel free. There was one question I just want to answer right away on the assembly side. Like, how do you know whether you should put a fiducial or not? If you have multiple BGAs on the board, you should have fiducials. And for, a regular board, it's always good to have 3 global fiducials. If you don't do that, then we are doing that on the array outside of your board, or we'll ask for a deviation to be able to put fiducials on your board. And again, as a designer, I wouldn't want a fabricator putting any copper, on my board without me knowing about it. So the portal serves that as that communication, like, hey, we'd like to do this. Is that okay with you? And that's why we're asking. But if you can do that ahead of time, all the better.
Okay, thank you. While we answer the Q&A, can I just do another poll?
Sure.
Okay, there you go. You only have 2 questions. And we can start answering the questions.
You want me to go through?
Yeah, there's one question about KiCad. I'm not sure I got it. Can you answer?
Sure. Yeah, so we do have standard stack-ups within the KiCad app. Do we have a capabilities template? I'll have to ask the design engineering team if they've created that, but I think the answer is yes. So we'll get back to you with that. We'll send it over. The other question Keith had was, is your DFM tool Valor? I don't know what you mean by Valor. So Valor split off from Orbitech, and I think Orbitech focused on PCBs primarily, and Valor focused on everything, fab and assembly. And so we're using the Frontline Genesis as our DFM tool, not Valor, which is assembly. So if you're looking for Valor for DFA, that's not the case. This is the tool right now is just PCB DFM. So I think David has some good questions on impedance and trace routing. David, I'll send you some good information you can reference offline. I'll give a quick example. From a manufacturing perspective, routing, let's say you're routing 10 traces and the route distance is 5 inches and they're all in straight lines. That's what I mean by parallel traces. And that becomes hard to manufacture. And in terms of, signal integrity, you're going to have to, make sure you're properly, thinking about, keeping your trace separated, protected, with the proper spacing requirements. And I'll send you the guidelines on that. You can follow 3W and that would be ideal. But I'll send you some more details. We can look at that. And then, in terms of impedance, you put the impedance on your fab drawing requirements, and then if you can in your data, say that, like, let's say your strip line would have a spacing, or sorry, a trace of, let's say 4.1. That makes it easy for us to immediately know which traces are we talking about, which nets and traces we're talking about. And that's how you link your Gerber data to the fab drawing. It's a little trick that does that, and I think that's great. And then someone's asking, I'm assuming Beverly's asking a little bit more detail about what makes manufacturing parallel traces a little harder. And I think we have Steve Carney. He can give you a rundown, like a super detailed rundown if that's what you're looking for. But just so you know, PCB manufacturing is a wet process these days. And so wet process means that even if you're controlling your process, every design is different. But Steve Carney, are you there to answer why parallel lines are difficult to manufacture?
Yeah, I'm here.
Don't say they're not.
It depends on how long they are.
Yeah.
So basically, we're using a dry film resist, and so it kind of gets into the line width and the spacing and all of that. So it's more of a design specific issue. If you get really long parallel lines, there's both some imaging and some etching and wet processing issues. But if they're fairly short, those defects are they don't show up. So yeah, it's a more of a design specific problem.
Yeah.
Does that answer your question?
And I hope so.
It gets kind of complicated, but yeah, it has to do with the resist and the plating and all of that. So yeah, it's like I say, it's a design specific issue.
It is, and I think that if the designer can, ask about it, right? So if you're designing parallel traces and they're 3 inches long, ask your fabricator, are you going to have problems with this specific feature on the board? And same with like if you have coils on your board, I would call those out, so your fabricator can be more aware, and because the coils are another form of parallel traces, right? And you're going to get different performance if there are shorts in the coils. By shorts, I mean bridging, between the copper. So if you have special etched features on your board, on an inner layer or outer layer, you should really call those out and call out the tolerances on those ahead of time. Okay, great. Well, thanks everyone.
Hold on, did you see Beverly's comments?
No.
There
Yeah,
was a question about the flex
yeah.
running long. So if you look at those, those are those have really big spacing. So where you get into problems, the job that we've had some issues with, the line spacing is really dense. They're really close together. So that's a whole different, typically flex, you have one or two, connector, trace lines on there, and they're like, 30, 40 mils apart. So what Amit was talking about is when you have, 5, 6 inch long lines, they're 3 mil wide and, 3 mil spacing, and that's a whole different set of issues. So like I say, it's more of a design specific issue. It doesn't apply to everything. It just, gets into higher density kind of stuff.
And I don't mind sending you snapshots of what we've had problems with in building. And I mean, we don't build Flex any different from anyone else. So, yeah, I'll send some snaps.
Okay, there's one more question.
We do subtractive.
Okay, I think we're done for today. That was a lot of questions and a lot of slides. Thank you so much, Amit, for presenting. Thank you, Vandana, for doing the demos. Thank you, everyone who joined. If you have any other questions, you have my email. So shoot me an email and we'll get back to you. Thank you, everyone, for joining. Have a great day.